Hey guys, this is Maths Methods Sharpened Study Guide question MM091. So we've got a question on the axes below. Sketch the graph of f of x, which is this hybrid function here. Basically a hybrid function is simply two graphs on the one axis with different domains. So we've got x squared take 2x take 3 where x is less than 2, and f of x equals 3 take x where x is greater than or equal to 2. So basically what we just need to do is sketch these two separate graphs and put them on the same axis. That's all a hybrid function is. So I personally like to start with the easier one. So I'm going to start with this, this linear graph here. So we've got, I'm going to do it on my own axis. So we've got f of x equals 3 take x, and x is greater than or equal to 2. So basically what we need to do is figure out how to sketch this linear graph. So we start by getting our x and y intercepts. So for our x-intercept, y equals 0, which means that 0 equals 3 take x, which means x equals 3. And then for our y-intercept, x equals 0, which means that f of x equals 3 take 0, which is 3. So our x-intercept is 3, 0, and our y-intercept is 0, 3. Awesome. Except that our x value is only above 2. So it's greater than or equal to 2, which means that it starts at that point. So this point at 0, 3, because our x value is 0 there, and that's not greater than or equal to 2, we're not actually going to have that y-intercept there. So basically we need to figure out where this graph starts. So let's put in our value of x equals 2, and we can see what our starting coordinate is going to be. So that's equal to 1, which means that our starting coordinate is 2, 1, and it passes through the point 3, 0. So 2 is, let's say, here, and it's 2, 1, so let's say here at this point. And because it's greater than or equal to, we need to do a solid circle here, and then continue through 3. So this is 2, this is 3. And because this is a -1, we know that the gradient in front of the x is a -1. We know that it's going down, which means that the graph has to go down like this. And that's it. So that's this one done. So we've made sure that we're only using the domain x is greater than or equal to 2. We've made sure of our x-intercept, our y-intercept, which would be 3 if it kept going up, and our starting point, which is 2, 1. So that's it for the second one. Let's go back to the first one, which is the parabola. So we've got f of x is equal to x squared minus 2x take 3. And I can see immediately that this is a easily factorizable quadratic, which factorizes to x take 3, x plus 1. And I like to do that to make it easier to find the x-intercepts. So in order to find our y-intercept, let's use the first one. So our y-intercept occurs when x equals 0. So f of 0 is equal to 0 squared take 2 times 0 take 3, which is equal to -3. So our y-intercept is 0, -3. And for our x-intercepts, I like to use this one because it's a much easier form. So f of x is equal to, so 0 equals x take 3, x plus 1. Because of our null factor law, 0 is equal to each one of these brackets here. So 0 equals x take 3, and 0 equals x plus 1, which means that x equals 3, and x equals -1. So we know that there's an x-intercept here at -1, and there's also an x-intercept at x equals 3, which is here. But because our domain of our quadratic is only x is less than 2, we have to stop the graph of the quadratic at x equals 2 and just follow it up left. So this is a positive quadratic. And sorry, this x-intercept is actually a -1. I'm sure you picked up on that before I did. So this is -1 here, and it stops at 2, goes through -1, goes through -3, which is, let's call it here. You'll have a grid on your axis, which will make it a lot easier. and that just goes back to infinity. So x is everything less than positive 2. So basically we need to figure out which y value the quadratic stops at. So let's sub in 2 for our quadratic. So we get 2 squared, take 2 times 2, take 3, which is equal to 4, take away 4, take away 3. So what that means is our end point is at 2, negative 3, which is 2, negative 3 here. And because this is not including 2, whereas this second one is, this is going to be an open circle, and our turning point is going to be somewhere here, but we don't actually have to label our turning points. So what we do is we know that it's a quadratic, something like this, like that. So this is our final answer. We have our quadratic here. I like to put arrows on the end. Doesn't really matter though. This is our quadratic, and all we need to do now is simply label all our intercepts and our points. So we've got 2, 1 here, it was, and our endpoint here is 2, negative 3. This is 0, negative 3, and this is negative 1, 0. So you always want to label all your endpoints and your intercepts just to be, I guess, proper and correct. But if the question doesn't ask you to label the turning point, then don't worry about it. So we don't need to worry about this turning point. Although in saying that, because the turning point is between 0 and 2, we know that it's at x equals 1, and then you would simply sub 1 in for, in fact, let's do that now. So we've got f of 1 equals 1 squared, take 2 times 1, take 3, which would be 1, take 2, take 3, which is equal to negative 4, which is actually almost exactly where I drew it. So this is at 1, negative 4. Awesome. So that's your final answer. And don't forget to write x and y on your axis, which it should actually have it already on the graph. But this is your final answer.